This video demonstrating how to generate a test pattern for a certain circuit. Firstly, we will translate the circuit into a VHDL code, and by using Leonardo Spectrum, the VHDL code will be converted into a gate level netlist. And by using the Fastscan, we will generate the test vectors of the circuit. Here is an example. We will use it in our demonstrating for the two tools, which are the Leonardo Spectrum and the Fastscan. Firstly, you should create a folder. Here, for example, I created a folder named test, and I write by using the notepad the VHDL code that translates our circuit. Here is the library we included in firstly in the code, and here's the entity which describe the inputs and the outputs of our circuit, and here's the architecture that describe the gates used for the circuit to produce the output. If you have any questions about the VHDL, if you don't remember VHDL, you can send me an email and we can solve this problem. To save it with a .vhd, we will press File, Save As, and here we will change the type all files, and we will write test.vhd, save, and here we will see that there is another file created in the folder, and if we check the properties, we will see that it becomes the type of the file becomes .vhd. Okay. Then we will open Leonardo Spectrum. You'll find it here in the desktop. Make sure that it's Leonardo Spectrum level 3. Okay. Then here in the technology, we will choose ASIC, Mentor Graphics, TSMC 0.35 micro. This is the technology we will working on it. And then here in working directory, we will choose our file. Here C, and our folder is test. This step to set the working directory, you will see here set working directory C test, and then we will press open files, and we will choose the file we created with test.vhd, open, and then we will press run flow, and here the file is processing, and when we see O2 write test_0.vhd, we will know that our netlist is created. And to make sure that this folder is created, we will go to folder test, and here you will see test_0, which this is the file include our netlist for the circuit. For this step, our work with Leonardo Spectrum finished, and we will close Leonardo Spectrum like this, and we will open the virtual machine for using the Fastscan to generate our test vectors for our circuit. You will press here open virtual machine, and make sure that you choose C, Fastscan RH5, and here clone of Red Hat Enterprise Linux 5, open. And then you will press play virtual machine. Here's the virtual machine is opening. This is the last time that I opened Fastscan, so it's opened already, but we will close it like this. And you'll see here shortcuts for different programs. We will press the shortcut for the Fastscan, and it will open it like this. Before working with Fastscan, we will minimize the Fastscan like this, and also we will minimize the virtual machine, and we will go here in the folder we made, and we will copy the file test_0, which is the netlist created by the Leonardo Spectrum, and return back to the virtual machine. We will create a folder here, call it test only also, and we will paste our file like this. Okay. Here we will see the instances that used to create our circuit. We will observe that we have two instances are used for creating the circuit. The first instance is XNOR2 and the other instance is XOR2. In a normal VHDL code, you will find the component used, which is XNOR2 and XOR2 here in the place before the begin. So before we will use the file in the Fastscan, we will search for the components of the XNOR2 and XOR2 and paste it here in the file. Okay, to find the file that contains the components used by the Leonardo Spectrum, we will click Computer, File System, Home, Mentor, ADK3_1, Technology, and here is the file ADK_comp, and we will open it and then display. Then we'll close this one. Okay, so here we will search for XOR2 component, and here it is. We will copy it and paste it here before the begin in the architecture. So here's the first component used in the instances, which is the XOR2. The second one is XNOR2. So we will copy it and go to the file of the ADK_comp and write down here in the find the XNOR2 find, and here it is. You copy it like this, copy and paste it here before the begin. Close and save. So like this, the file is ready for using in the Fastscan tool. All what we made is to adding the two components used in the instances, which is XOR2 and XNOR2. Okay, so here we will minimize this and we will go back to the file of for the Fastscan. Firstly, we will choose the file test.vhd, which include the netlist and the components after we add it. So we will browse here, desktop, test, and we will choose the test underscore 0.vhd and then press OK. And here in the ATPG library, we will choose the library used by Mentor. So we will press here, move up, and move up again. We want to go to home, so we can write here in the file name home, and here is Mentor. Okay. Mentor, and then ADK3 underscore 1 technology, and we will choose the edk.etpg, which is the library we will use. Okay, and then we will press invoke Fastscan. Okay, first we will press done with setup, and that we want to make a setup for the test generation, for the test pattern generation. We will choose pattern generation. There's more than one function that we can make with the Fastscan, pattern generation, fault simulation, and so on. So we will use the pattern generation, which is our goal. And then to make test generation, we have several setup we will use. Firstly, the fault universe, we can press here. We have the two options. We have the typical one and we have the customized one. The typical one that we will generate the test patterns that can detect all the faults in the circuit using the model of the stack at faults. Here it's written stack at fault model and all faults in the design. While the customize, you choose the node that you want to induce the fault at. So let us explore the customize one. Here, customize, and the fault model will be stack at faults. Here you can browse the hierarchy to set your the node that you want to test it. We can choose the fault type to be stack at 0 or stack at 1. For example, we will use stack at 0 and then browse hierarchy. You will find this our circuits like a black box that have inputs and outputs. And also we can go further deep. Here we have, this is the instances we have in our code. For example, if we want to induce here in the X node 2, we can choose it like this. This is the instance IX118. And here is the inputs of it. We can say, okay, we will choose this instance for induce the fault here. And for example, input in a node is stack at 0. So we will choose a node like this. So here you will find that we want to generate the test patterns to detect the faults in instance IX118 and the fault in the input node, in the wire of the input node. Okay, and you can add it like this, and and OK, and then press OK, and the test pattern generated will use this pass. But if you don't want to do this, if you want to generate all the faults in the design, we can use the option of the typical, which we will use it now. Typical. Okay, so here we choose the fault universe. Let us choose the pattern source. Also here in the pattern source, we have options to be typical or to be customized. We will use the typical one, which is an internally generated pattern set. So we will use the typical one here. And then in test generation, here. So here is the setup. We choose this to be single stack at, so it will generate the stack at false 0 or stack at 1 for all the faults in the design can be, and the pattern source is internal. Then press run with existing settings. And here is the results, test coverage, fault coverage, and ATPG effectiveness. Okay, then we can press run. And then press dismiss. So to save the generated patterns in a file, we can press generated patterns here. And if we want to save it in a specific file, so we can go back here in the folder test and create an empty file. We will call it also test. This file will be in the extension ASCII ASCII. Here is the file, which is now empty. If we open it, it's an empty file. But here, so the test patterns will be written here in this file. Okay, minimize it like this, and here we will choose to save it, pattern to a file, and here we will determine the class name, desktop taste, and we'll choose this one. Okay, and you can choose also overwrite existing file, and then press OK. And if we go here, go back here, we will see that the file includes the test pattern. Yeah, here it is. Here is the test coverage 100%, the total number of faults 44, and the patterns used to detect all the faults in the design are 5 patterns. And if we go down here, you will see this. This is the inputs of the design, and this is the output. And here is the 5 patterns generated. Here is the pattern number, and here is the input vector used, and this is the expected output for this pattern. And that's it. If you have any question, please email me. Thanks.